Kia ora, Year 12. Here are two more questions from Thursday's test. So in this one, I'm going to do a DE question that was reasonably well done, and then a partial fractions question that was really, really badly done. So I'm hoping that by watching this and doing this question, you're never going to make these mistakes again. I might be being a little optimistic. A lot of you need to review Chapter 7, and you need to look before you start to do things in the maths exam. Okay, so the first one, the DE question, we've got two variables, we've got x and we've got theta, and everything starts off all mixed up. So 3 plus cos 2 theta times dx by d theta is equal to x sine 2 theta. We're given that when x is 3, we've got theta is equal to pi on 4. So we have to solve the DE. We have to get an expression for x in terms of theta. So take that all the way through to making x the subject. And then we have to state the least value taken by x. So this is a really nice little 1 mark icing on the cake question. Okay, so most of you did really well with separating the variables. Let's have a look. Let me just find my working so that I'm not writing it out wrong. Okay, so we started off like this. And we're going to get all the stuff with x onto one side and all the stuff with theta onto the other side. So working first with the x stuff, we've got dx here. So we're going to divide both sides through by x. That will give me 1 over x dx. I'm going to multiply both sides through by this, and I'm going to divide both sides through by this. And that gives me sine of 2 theta over 3 plus cos of 2 theta d theta. And I should be feeling really good about integrating this because this is easy. And this is also really good, right? Because we should be spotting by now that we've got a function of theta here and we've got a multiple of its derivative here. So both sides are going to involve logs. On the left-hand side, I'm going to get the natural log of x. And on the right-hand side, I'm going to get something times the natural log of 3 plus cos of 2 theta. And I'm going to put my constant of integration on this side. I could have done it here. It doesn't really matter. So what's this constant here going to be? Well, when I differentiate the inside function, I'll get negative 2 sine 2 theta. And I just want to have 1 sine 2 theta. So my constant is going to be negative 1/2, and that will undo the negative 2. And that was reasonably well done. So the next thing we have to do is use the fact that when x is 3, theta is pi on 4. And I can also start to drop some of the absolute values. Not that that matters too much. They're not very fussy about that in Cambridge exams. But let's just leave that there for now. So the log of x, let's fix it up. We're substituting. The log of 3 is equal to negative 1/2. Times the log of 3 plus cos of 2 pi on 4, which is pi on 2, plus c. So what we're doing here is we're going to solve, we're going to make c the subject and find what c is. So the log of 3 is equal to negative 1/2 times the log of 3, because this is 0, plus c. Now there's no point doing anything complicated with this, and I saw some of you do crazy things. Well, not crazy things, right? But like you put the 3 to the power of negative 1/2. So you were writing it like this. If you look at what we're trying to do, we're just trying to get a value for c. And we've got some nice like term things here. We've got a log of 3 here, and we've got negative 1/2 of log of 3 here. So we're going to add this to both sides, and we'll get 3 over 2 log 3 is equal to c. Okay, so we've found our constant, and now we're going back to this equation here. The other thing that we might as well notice along the way is that because cos of 2 theta is between negative 1 and 1, this thing here will be between 2 and 4. So we can ditch the absolute value signs there. This gives us the natural log of x is equal to negative 1/2 times the natural log of 3 plus cos of 2 theta. Oh, what am I doing there? I've got rid of them. Plus 3 over 2 times the natural log of 3. Cleaning this up a bit, I can combine my logs by taking out a factor of 1/2. So I've got 1/2 times 3 log 3 minus the log of 3 plus cos theta. So the log of x is equal to the log of, what am I doing? We'll leave the half here. The log of 27 over 3 plus cos of 2 theta. I'm sure I've lost a 2 in there. Yep, sorry guys. Yeah, there it is, it's come back. And that gives me x, the log of x going very slowly, is equal to all of this to the power of 1/2. So all of this stuff here is your level 2 NCEA algebra rules about logs, right? There's nothing complicated about it. You just have to have done enough fluency work that it's not feeling too hard. So now finally we can e both sides, exponentiate both sides, and we get x is equal to this. And that's 7 marks. Then the last question asks us, state the least value taken by x. So the least value taken by x is going to depend on what value of theta we've put in. And we know that this fraction is going to get smaller when the denominator gets bigger. So cos of 2 theta plus 3 will be between 2 and 4, right? Because this is between -1 and 1. And that means that the smallest value of x will be when cos of 2 theta is equal to 1. So the minimum x value is going to be this, root 27 over 3 plus 1 over 4, which is equal to 3 root 3 over 2. All right, now I'm going to do the next question, which I think the first part is really boring, but really important that you can do it well. We have to express f of x in partial fractions. And I was pretty shocked when I marked it that so far very few people have taken a look at this and said, well, here I've got a quadratic and here I've got a quadratic. So before I want to start partial fractioning things, I want to take out the constant term. So let's take a look at how we should be doing this one. So for 5 marks, we've got this, 4x squared plus 7x plus 4 divided by 2x plus 1 times x plus 2. Now I want to show you why doing what most of you did is just not going to work. So if you just put in an a and a b here, and we do our cross multiplying thing, we're going to get a times a linear factor plus b times this linear factor. None of that is going to generate us a quadratic term, right? So that clearly isn't going to work. So a slightly better approach that a few of you took was to figure out that you needed to get that quadratic and to say, well, if we have ax plus b for one of them, we should get there. And so then you found 3. Now, that's a lot more work than what I'm about to show you. A couple of you did manage to get, in the end, I gave a couple of you full marks for doing it that way, but it's just much more complicated. So the best way to look at this is to go back to the start. And this is done in chapter 7. And let's expand this bottom line. So we get 2x squared plus 5x plus 2. So you can see that we're going to be able to get 2 whole ones of this out of the top line, also called the numerator, and have some leftover stuff. So this is going to equal the following. We're going to have 2 times 2x squared plus 5x plus 2. So that's 2 wholes. And now here I've got 10x and I only want 7. So we're going to take away 3x and I only want 4 and I've got 4. So what we've got is this. We've got 4x squared plus 7x plus 4 over this is equal to 2 plus a over 2x plus 1 plus b over x plus 2. So all we're partial fractioning is this, negative 3x over this. So that's what we have to work out now. Now I've worked out 3x and then shoved a negative in front at the end. So 3x into this comes out very quickly. Three x is identically equal to a times x plus 2 plus b times 2x plus 1. I'm going to sub in x equals negative 2, and we get negative 6 is equal to 0 plus b times negative 4 plus 1 gives me negative 3. B is equal to 2. Now I'm going to do matching to get the other term, because here I've got 0 plus 3x. So we've got 0 is equal to 2a plus b from here. So a must equal negative 1. So we're finished now, and we've got this here going all the way back up to here. We've got two holes. Let's see. So here's my 2 constant, and then my minus 3x. So I'm going to write that out slowly, because if we muck this bit up, we are going to be in trouble for the integration. So we've got this equals 2 holes minus a and b. What was a? A was negative 1. Sorry about the cursor noise. I have no idea why it's being so loud. So I've got 2 plus 1 over 2x plus 1 minus 2 over x plus 2. So that's your 5 marks for that. Now it's just boring, right? It's not that difficult once you've remembered what to do. The next bit is pretty fast and quite cool. We get the integral from 4 to 0 of 2 plus 1 over 2x plus 1 minus 2 over x plus 2 dx, which equals 2x plus, now leave a gap for the coefficient, the natural log of 2x plus 1. Now when we differentiate that, we get a 2 coming out. We don't want it, so we divide it out. And here we get minus 2 times log of, natural log of x plus 2, evaluated between 4 and 0. So putting in the 4, we get 8 plus a half log 9 minus 2 log 6. And don't think that all of the next bit's going to be 0, because it's not, but we're going to have 0 plus a half log of 1 minus 2 log 2. Now it's time to do the cleanup. We get 8 plus the log of root 9 minus the log of 36 minus 0 plus 0, so plus the natural log of 4. So we get 8 plus the natural log of 3. And then here I'm going to combine those two to be plus the natural log of 1/9. Now look where we're trying to get to. Where are we trying to get to? Oh, all the way back up here. Hang on, where is it? Yep, we're trying to get to 8 minus log of 3. So you can see we're getting pretty close now. It's a show that question, so we do want to make it pretty obvious that we're not just skipping to the bottom line. So that's plus the log of 1 minus the log of 9, which is 3 squared. 8 plus log of 3 minus 2 log of 3. I don't know, you could have skipped one of these steps, but I wouldn't skip too much. There, equals 8 minus log of 3 as required. And I've made a video that's got 30 seconds left to go. So thanks for watching. I will do a few more of the test questions tomorrow.